Good morning. We're starting section 5.2.3 today, where we will be graphing log functions with different bases, and we will begin from a table of values of the log function. We will be using strategic inputs, and this is what we should always do when we graph logs. Those strategic inputs for our table of values will be the base, so whatever the base of the log is. We'll always use 1, and you should always use 1 over base. If possible, another great input is the base squared. So that's another good input to try if you can. Depending on what the graph is, you might be able to squeeze in the base squared. So I'm going to begin and most likely separate this video into 4 different sections. But this problem, 575 and 576 combined together, is to graph log base 2 of x, followed by log base 3 of x, log base 4 of x, and log base 10 of x. So for each one, I will create a unique parent graph. So again, the guidance is to use the base. So the base of this log, again, this is said log base 2 of x. The base is 2. We will also put in 1. We'll put in 1 over the base, which is 1/2. And like I said, if you can squeeze in the base squared, which is 4, that's great. So one way to start is obviously when you're evaluating a function to plug in that input. And so log base 2 of 2. Now thinking about rewriting this into the equivalent form, we're trying to figure out what does that output. So if you remember that we can rewrite this in equivalent exponential form as 2 to whatever this output is. So 2 to the output we're looking for. Again, 2 to that output equals, again here, the answer. So one thing to remember is that when you're thinking about rewriting logarithms, they're in the form of log base of the answer equals the exponent. Again, log base 2 of 2 would output, in this case, 1. Since, again, 2 to the first power gets me to that 2. Likewise, moving a little bit quicker, log base 2 of 1, if I rewrite this, this is the same thing as thinking 2 to some power gets you a 1 out, and that is only going to be 0. Followed by log base 2 of 1/2. Well, rewriting this is again 2 to what power gets you to a 1/2? Well, that's again a -1. Finally, the last input, log base 2 of 4, rewriting that in an equivalent exponential form makes it easier. 2 to what power gets me to the 4? Well, that answer is again 2. So you'll see that again, the base squared output is getting you out at 2. So I will go ahead and plot these points on my graph here, being careful to plot them accurately. So again, when I inputted the base 2, I got out 1. That will always happen. When I put in a 1, I always get out a 0. All logs, unless they've been translated, are going to go through this point, 1, 0. Then again, we had 1 over the base, which was 1/2, getting me out a -1. We also put in base squared, which gets me out a 2. If you think about base cubed, the base is 2, cubed is 8. That would actually get me out a 3, which I can squeeze on my graph as well. So I'm going to go ahead and connect these. One thing to remember is that you should show that this logarithm graph continues on along next to the y-axis, but it never ever crosses over it, and you need to show that with an arrow. So I'm going to go ahead and highlight that there is a vertical asymptote for all logarithms along the y-axis. Now, of course, if it's gone through a translation, then there'll be an asymptote somewhere else. But in this case, the asymptote has not been horizontally shifted, so there's again a vertical asymptote at x equals 0. And that again, x equals 0 is this equation for the y-axis. So that is the first graph. If I were to completely describe it, I would also need to describe the domain and the range for this particular function. And so again, for the domain of this function, the domain are going to be x values that are greater than 0, not equal to 0, because again, that is where our vertical asymptote is, that we don't cross over. And for our range for this particular function, it would be all y values that come out, because as you see, this graph will continue on towards negative infinity on the y-axis, and likewise, it will go out to positive infinity along the x-axis. So again, the range would be all real numbers, and all real numbers is the same thing as you'll see on the slides as from negative infinity to infinity. That is, again, how you graph log base 2 of x, starting just from its function, not starting from its inverse. But there was a question for each one of these, and it says, well, what is the inverse equation to log base 2 of x? The inverse to a logarithm is an exponential function of the same base. So to write the inverse function's equation, y inverse would equal 2 to the x. Please watch the next videos if you need support in graphing log base 3 of x, log base 4 of x, and log base 10 of x.